Okay, so just take this space where the domain of every function is -1 to 1, okay? First of all, what does the graph of sine of n pi x look like? Well, here's -1, here's 1. It's 0 here, it's 0 here, right? And it goes through n complete cycles between here and here, okay? And it's also equal to 0 here, because the sine of 0 is 0, right? The sine of pi is 0, the sine of negative pi is 0. Just, again, unit circle. Here, here, or here, you project to the 0 value of y, okay? So, in general, you might have 1, 2, 3 cycles. Okay, here's the sine of 3 pi x. That's what the graph will look like. I mean, it'll be a little prettier than what I drew, but that's what it'll be. Okay? Now, each of these arcs above or below the axis has exactly the same area, right? Because of the symmetries and so forth. Okay? How many arcs do we have above the axis here? We have 1, 2, 3, 4, 5, 6. How many do we have below the axis? We have 1, 2, 3, 4, 5, 6. What's the integral? Pardon? 0. Because anything above the axis is positive, anything below the axis is negative. Okay? So, I'll use PQ again. The integral of, or the inner product of any two functions is still P of x times Q of x dx, okay? But now we're integrating from -1 to 1. Okay? So let's see, what's the magnitude? Now actually you don't know how to graph, you don't know how to integrate the sine squared, I don't think. Because from what I understand, you're just now doing a little bit of substitution, right? Integration by substitution. So you kind of need integration by parts, or the substitution you need, or the change of variable that you need to do the sine squared is a little more subtle. You probably won't do that this semester. Okay?
The integral of sine is cosine, right?
I'm sorry?
The integral of sine is cosine, right?
Negative cosine.
Negative cosine.
Yeah, antiderivative, and if you use substitution, you can easily integrate the sine.
Right.
But if we want the, okay, I'm going to do this. Well, first of all, the magnitude of P and I say you want to write out the definition. It's the integral of P squared. Okay? You don't know how to integrate sine squared, so you don't know how to get the magnitude of this thing. Okay? So I'm just going to tell you one more thing about it, then I'll ask you to do a couple of things with it, okay? But the thing is that the inner product of the sine of n pi x with the sine of m pi x is 0. if m isn't equal to n. Okay? And that's because if you have 4 peaks here, say, between here and here, on one function, and 3 peaks on another, it's going to end up giving you as much area below as it does above. Okay? Now, if you do the sine squared, everything's going to be above, right? You're just going to have a bunch of arcs above the axis. Okay? So we're not going to actually do that, but I want you to be aware of this because this is a very important function space. Okay? This is the basis for Fourier analysis. And you will talk about that next semester in calculus. Okay? Not the inner products, but you'll see some of this.